Okay, so yeah, I don't think that would make it onto YouTube, so we won't worry about that. But yes, now we're live, so watch your language. Please review some factoring for me. Do you remember how this goes? Basically, last time we did look a little bit of factoring when we did completing the square, but this is sort of like the idea that we're going to work on, which for you guys now I know it's pretty straightforward to do this process. But you want two numbers that product is 6 and add up to 5. So what do you think? Two numbers to factor this? 1 and 5?
20.
Yeah, 2 and 3 are going to multiply to 6. So 2 times 3 and 2 plus 3. So those check out. So we could factor this as x plus 2 and x plus 3. So that's what we're going to practice here in order to solve some quadratic equations, and you'll see how they get connected in just a minute. So I'd like you to try these ones out and see how you do with factoring the examples up on the board. Okay, so again, the pattern is it's going to be two numbers that add up to 14 and multiply to 45. So what do you think?
5 and 9.
Yeah, 5 and 9 will work. So that'll be x minus 5 and x minus 9. Because negative 5 times negative 9 will be positive 45. And if I take negative 5 plus negative 9, I'll get negative 14. Okay. This one here, you can pretend like there's a plus 0. So somewhere in there you need a 0. That means I want them to multiply to 0 and add up to negative 8. So that's a pretty easy set of choices. It's going to be x minus 8 and 0. And normally we never write something like that. We would just write it as x minus 8 and x. Okay. How about multiplies to negative 4 and adds up to negative 3? Sure, Jackie?
4 and negative 1.
4 and negative 1? Yeah, that'll work. So x plus 4, x minus 1. Yeah, sorry, I got it backwards there. Just going a little too fast. Part of my brain is still on spring break, although it is waking up slowly. It's nice to know that some of you are back with it. So a day of rest. A day of rest after spring break. That'd be good. Take tomorrow off then, right? So Alice, did you want to 42 and 13? What do I get for 6 and 7? Yeah. So x plus 6 and x plus 7. And negative 72, negative 1. Big number there, negative 72. Yeah, Robbie.
Positive 8 and negative 9.
Good. So positive 8 and negative 9. So that way 8 times negative 9 gives me 72. And 8 minus 9 gives me negative 1. Okay, and then I'll do the last one for you. Okay, so those are our factored forms. So for the difference of squares, that's one again that we've done when we, perfect squares is one that we've done when we did the graphing for completing the square. But for the difference of squares, you can kind of think of it like this, as x squared, there's a 0x in there. This is kind of like what we're doing. We're playing the same game, except they have to add up to 0 now. So two numbers that multiply to multiply to negative 25 and add to 0. Well, x plus 5, x minus 5. These two here, they will multiply to negative 25, and when I add them together, they cancel out as a 0. So this would be gone here. So what we want to do is look for this pattern. If we recognize it, there's a perfect square here and a perfect square here. Then what you're going to see is that it's the square root. This is 25 square root. And so is over here. So the pattern then becomes x plus 1, x minus 1, square root of 1. So we can do these ones really quickly if you recognize the pattern. X minus 9, that's perfect square, that's perfect square. So it's going to become x minus 3, x plus 3. Same thing here, perfect square, perfect square. So very quickly, x plus 2, x minus 2. So it's handy if you recognize the pattern. It's a lot less work to do there. It's a lot quicker. Okay. Now perfect square, I mentioned we had talked about this for graphing. So do you remember how the pattern goes? Remember what we did to make it go quickly when we graphed them? We had to follow a pattern to make, if we want to know that they are a perfect square, there was a pattern that we had to see there. You guys wait. You clearly have studied a lot of math over the break. Looking to give you a break? Yes. Yeah, so that's what we want to check is if we divide it by 2 and square it, does it match up? So 2 divided by 1, and then I'm going to square, oh, sorry, got the answer already in my head. It's 2 divided by 2 squared, which is 1. So it does check out because this number divided by 2 and squared equals 1. So it is a perfect square. And do you remember what the number in brackets becomes if you recognize a perfect square? Like I'm trying to fill this in as a perfect square. Do you remember what goes here?
The number you got.
Yeah, the number that I divided by 2. So that's going to be 1. Okay. So we check the pattern here. 6 divided by 2 squared is 9. So yep, that works out. Then what I'm going to do is put in x plus 3 squared as my factored form. And remember, if for some reason you blank out and you forget all about those shortcuts, that's okay because you're still looking for a number that multiplies to 9 and adds to 6. So if you choose 3 and 3, you get x plus 3, x plus 3, and you still be able to answer that question. Okay, but the shortcuts can be useful to help move you along a little faster. So is this next one here a perfect square? Raise your hand, I guess, if you think it's. Let me see who's still alive after the spring break. Must have been a good spring break if some of you came to school dead. Good, okay. So yeah, that one is a perfect square. We can factor it as x plus 5 all squared. Okay. And how about that? Is that a perfect? Is that the right way to do this one?
No.
What's wrong?
Negative.
Yeah. It's okay. So be careful. Don't go super quick. This should be a minus because when I divide 8 by 2, I get -4, not +4. Okay. So that number was negative. Okay. So those are pretty much the standard cases, which I know we would zoom through those. But what about when there's numbers in front of x? That's what we're going to talk about for the rest of the block and some strategies for that. So these initial ones, I'm going to show you the first one, then I'll let you get started on your own. First strategy is always greatest common factor. So number 1, we're always going to try to take out the greatest common factor and hope that things will work out. So for example here, everyone's divisible by 2. So I would rewrite this question like this before I went on any further. Okay? So then if I think about it, 2 numbers that multiply to 20 add up to 9. That's going to be x plus 5 times x plus 4. So that's how I'd factor it by taking out the greatest common factor first. Okay, so you try the other ones and we'll catch up and see how you did.